All right, let's talk about something that's, truly the backbone of professional video infrastructure.
Mm-hmm.
When you need to push uncompressed, high-def video, we're talking speeds up to 3 gigabits per second, that's 3G-SDI, across, say, an entire campus.
Yeah, that's a big ask.
It is. It requires some really specialized hardware. So today, we're doing a deep dive into one of those workhorses,
Mm-hmm.
the Thor Broadcast F-1SDI-3G-TxRx-RM.
Right.
Our mission here is to sort of figure out what makes this single-channel system such a brilliant go-to solution for that kind of mission-critical work.
Well, fundamentally, you're looking at a dedicated shortcut for these incredibly high-speed signals. It's an uncompressed fiber optic transmitter and receiver kit.
The TXRX pair.
Exactly, a TXRx pair. And is built specifically to handle those really fast serial digital signals all the way up to 3.0 Gbps. And the key thing, it does it all over one single strand of optical fiber.
Okay, hold on. You said 3G-SDI, which is, it can be notoriously finicky.
It can be.
But the sources we have claim this is truly plug and play. That means zero configuration. It auto-adjusts to any input signal type, SD, HD, 3G, whatever.
Yeah.
Are we really talking about a system that requires no management at all? That just seems almost too good to be true for something this fast.
It does sound a bit like marketing magic, doesn't it? But really, it's just pure engineering efficiency.
Okay.
The unit is designed to just look at the signal you throw at it, instantly adapt to the bitrate, the protocol, and just fire it across the fiber.
So it takes all the guesswork out of it.
It removes huge layers of complexity and, frankly, cost during deployment. And that's the real operational selling point.
But let's shift to the hardware then. The foundation. It's
Yeah.
a standard 1RU rack mount unit, and it's built on this really robust 40-kilometer platform.
Right.
But the elegant part, like you said, is how it uses just one fiber. So how do you get a transmit and a receive signal across one tiny piece of glass without them, colliding?
Yeah, that is the brilliance of something called coarse wavelength division multiplexing. CWDM, right? So instead of needing two physical fibers, which is the old way of doing it, the unit uses two different colors of light, or wavelengths.
Like separate lanes on a highway.
Exactly like that. You have separate lanes on the same fiber highway.
Mm-hmm.
They're usually grouped into the 1310 nanometer and the 1550 nanometer bands.
And the really strategic takeaway there is just cost saving, right? With CWDM, you immediately cut your required fiber count in half.
In half, yep. It simplifies cabling, your infrastructure, your long-term maintenance inventory, all of it.
Wow.
And the system also ensures that signal integrity really holds up over those huge distances. It doesn't just pass the video.
It passes the embedded audio and all the data, too.
It passes everything, all the ancillary data. Plus, it has input equalization and reclocking.
Which basically cleans up the signal.
It cleans up and stabilizes the signal before it even hits the fiber. And that's absolutely key for making sure the video looks perfect, even after traveling 40 kilometers.
That reliability is just vital.
Yeah.
And speaking of reliability, the sources mentioned it's built to operate in some pretty tough environments.
Oh, yeah.
It can handle temperatures from, minus 10 Celsius, all the way up to a sweltering plus 55 Celsius.
If it's a tank.
So let's wrap this up for you, the listener. What we have here is high-speed, uncompressed video transport up to 3.0 Gbps over these really significant distances.
All built on that robust 40-kilometer platform.
And it does it using these simplified auto-adjusting optics.
Mhm.
It's really just operational simplicity applied to incredible speed.
And, maybe a final thought on just how massive the scalability of fiber is.
Cool.
While this F-1SDI is a really powerful single-channel system, the source material mentions that for people who need much higher density, dense wavelength division multiplexing systems are available. DWDM.
So even more colors on the fiber.
So many more. That technology allows for enormous scaling. We're talking up to 160 independent channels on that same single fiber. It just highlights the absolutely explosive potential of fiber optics when you're designing modern broadcast infrastructure.